There's a clear shift for many in the data industry, where the point where traditional data engineering principles align with new AI innovations to help ensure quality and automated memory management are converging. And that's what we're exploring in this week's deep dive based on the Data Pro newsletter from May 13, 2026. And don't forget to check out the audio podcast version on this as well. It's available on all podcast platforms. It's a much deeper dive for data professionals with a whole bunch more information, which if this is a topic you're interested in, you might get a lot more out of.
Welcome to the Explainer. Today, we're taking what we call the lean Claire approach. Now, if you're a fan of comic art, you know that classic clear line style is all about stripping away the messy, distracting shading to reveal the stark, clear architectural reality underneath. And we are applying that exact same lens to the Anthropic code with Claude 2's 2026 keynote. We're cutting straight through the AI hype to expose the concrete infrastructural reality of where this tech is actually heading. Let's dive right in. Here's our architectural blueprint for today. We'll start with the end of the AI hype, then look at agents as data infrastructure, quality gates and outcomes, governing agent memory, the economics of AI, and finally, the engineer's new playbook. Section 1. The end of AI hype and the shift to compute plumbing. You know what was totally missing from this keynote? There were zero breathless claims about artificial general intelligence arriving tomorrow. No dazzling, over-the-top flagship model announcements either. Instead, the focus was heavily on the underlying compute plumbing. It's a huge signal that frontier models are now good enough, and the real bottleneck is the heavy machinery surrounding them. To really ground this narrative in physical reality, just look at this number, 220,000. Anthropic announced a massive partnership with SpaceX to tap into the full capacity of the Colossus 1 data center. Within just a month, that's providing over 300 megawatts of new capacity, which translates to over 220,000 NVIDIA GPUs. That is the stark physical reality making these new operations possible. And this stat right here brilliantly illustrates exactly why that compute is so crucial. Anthropic's API platform just hit a 17x year-over-year growth. 17 times. For data engineers, raw compute translates directly into what actually matters, much higher usage limits and rock-solid reliability. We're already seeing Claude Code's rate limits double and API constraints relax. The foundational technologies of the future, they aren't the ones with the flashiest demos, they're the ones that become perfectly predictable and incredibly well instrumented. All right, Section 2, agents as data infrastructure, moving from novelties to operations. We are definitely moving way past the novelty phase here. Large language models aren't just these occasionally useful sidekicks anymore. They are rapidly becoming schedulable, highly observable components embedded right into our production systems. Notice the stark contrast here. On the left, we've got the chat era. That was all about tinkering, right? Clever prompting, playing in isolated sandboxes, simply chatting with tools. But on the right is our new reality, the infrastructure era. Now we're talking about persistent sessions, real-time event streaming, and tightly managed cost controls. The winning teams won't be the ones writing the cleverest prompts. They're going to be the ones treating model work exactly like any heavy-duty data workload. So the absolute crucial takeaway here is understanding what Anthropic actually means by managed agents, because it is not a chatbot. Think of it as a highly opinionated runtime, essentially a heavy-duty job runner for model-driven tasks. It provides a robust execution environment paired closely with a control plane. In this environment, a job might run for minutes or even hours. Artifacts get written directly to persistent file systems, and events are streamed seamlessly. It has the exact same standard failure modes and operational concerns you would expect from an enterprise orchestrator or a data warehouse. Now, if all this new terminology sounds a bit intimidating, let's just map these new Anthropic features directly to data engineering concepts we already know and love. Anchor the unknown to the known, right? Multi-agent orchestration? Honestly, that's just controlled fan-out parallelism, and it's limited to 25 concurrent threads, making it nicely bounded. What about outcomes? Think of that as your data quality checks. The new dreaming feature? That maps perfectly to data compaction. And their advisor strategy? That is literally the AI equivalent of tiered storage. Suddenly, this whole landscape looks a lot more familiar, doesn't it? Moving on to Section 3, quality gates and outcomes and putting an end to silent failures. Look, if you integrated LLMs early on, you already know the biggest headache in the entire industry. It's when models spit out something that looks completely plausible, but is actually fundamentally flawed. They fail silently, and it creates an absolute operational nightmare. To solve this, Anthropic introduced outcomes, which essentially mimics task-driven development. Here's how the explicit grading loop works. First, you define exactly what done looks like. Second, the system executes the session. Step 3 is where the real magic happens. A completely separate grader model, using its own distinct context window, evaluates the work against your rubric. It deliberately doesn't use the same reasoning that created the work to grade it. Finally, step 4. The system iterates until that specific outcome is fully met. This explicit quality gate takes ask the model again and turns it into a highly structured, inspectable pipeline. Okay, section 4, governing agent memory and treating that memory as a real asset. So, Anthropic teased this really fascinating research preview called Dreaming. Basically, it lets agents reflect on their past sessions asynchronously so they can reorganize their own memory. They merge duplicates, replace stale entries, surface new insights. It's super cool. But treating memory as data raises a massive governance red flag we have to talk about. A derived memory store is still exactly that, derived. If an agent system is out there rewriting its own state, it can easily introduce errors or accidentally optimize away crucial nuances. Just like in traditional data systems, this demands strict lineage, absolute auditability, solid versioning controls, and, of course, the ability to roll back. Section 5 already, the economics of AI and making cost routing a standard. Let's be real, operating these massive models is definitely not cheap. So to handle this at scale, Anthropic formalized a concept they're calling the advisor strategy to tightly control costs. Let's break down how this routing mechanism functions. First off, you route your standard, everyday work to a much cheaper, faster model. Second, the system continuously evaluates the business impact of the task or the model's level of uncertainty. Third, and only when absolutely necessary, it escalates to consult a heavyweight frontier model like Claude Opus to step in as an advisor and resolve the really complex issues. This is exactly the LLM equivalent of tiered storage and workload management. And honestly, the results are incredibly compelling. According to the keynote, one customer actually took this exact tiered strategy and achieved frontier model quality at a 5 times lower cost. 5 times! This proves that inference routing isn't just some clever hack anymore. It is rapidly becoming the foundational economic strategy for running model-driven workloads at a true enterprise scale. And finally, Section 6, the engineer's new playbook and our practical takeaways. All right, based on these stark architectural realities we've drawn out today, it is safe to say the tinkering phase is officially over. So here is your rapid-fire action plan for serious engineering teams. 1. Stop treating LLMs as purely application layer problems. You are dealing with containers, file systems, and event streams now. That is pure infrastructure. 2. Adopt evaluation loops like outcomes as first-class design constraints. If you can't test for it, you do not have a pipeline. 3. Use bounded parallelism where it fits. Remember that hard limit of 25 concurrent threads? It's perfect for parallel investigation, but it's not for bulk data transformation. 4. Treat memory as data requiring heavy governance and rollback capabilities. And 5. Assume cost routing like the advisor strategy is the default standard for any build moving forward. So I want to leave you with this final, absolutely vital question. We've drawn the clear architectural line today. The exact same discipline you use for your data pipelines right now is the muscle required for this next layer of AI. Will you treat agent harnesses as rigorous production infrastructure from day one, or will you let them sprawl out into an expensive, ungoverned shadow platform? The choice is entirely yours. Thanks so much for joining us on this explainer, and we'll catch you next time.
Thanks for checking this out today. Don't forget, you can connect with other data professionals worldwide on our growing school platform. It's all linked in the description, so pop along, come in, have a chat, and check out the exclusive resources there for data professionals like you. And if you haven't done so already, please feel free to like, share, or subscribe to the channel.